What a happy day. Hello world. It's me, Ahmed Hassan from Digital Future Youth Committee. I'm a lecture assistant at the American University in Cairo and a senior architect based in Egypt. It's my honor to moderate today's session. I'm so excited. Today is my lucky day. Um, let's start our presentations. Our first presenter will be Diego. Please, Diego.
Okay, hello. I will share my screen in a second.
Okay.
Can you see my screen?
Yes.
Okay, thank you very much for the invitation. Just let me adjust this so I can present. Very sorry for this. Yeah, I am Diego Pinochet. I am currently a third-year PhD student here at the Design and Computation Group at MIT. I'm also a professor at Adolfo Ibáñez University. Trained as an architect, my interests range from like robotics, architecture, design in general. And I'm going to show you some of my research and some of the things that we cover in the Smart Collaborative Agents workshop. I like this quote from Pascal. I have to show it because this explains a lot why I do what I do. We must see the matter at once, at one's glance, and not by a process of reasoning, at least to a certain degree. Mathematicians wish to treat matters of perception mathematically and make themselves ridiculous. The mind does it tacitly, naturally, and without technical rules. And this has a lot to do with what I do, because even though I'm in love with technology, I'm always working in the intersection between technology and design and architecture. My research is focused on this transition from the idea to an object, being this object a building, a cup and a sculpture, a painting, and so on. So probably in the last 12 years, I've been working in this subject with different publications from, I don't know, ICADI 2008 till CAD Futures, for example, in this idea of interactive fabrication. So yeah, right now I'm focusing mostly in this, let's say, trichotomy between what I identify, sorry for the fonts are completely off, this trichotomy between idea, representation, and execution, and how technology basically is like, let's say, the glue that can reach to this process to be like successful, let's say. So I've been working with this as an architect, with this idea of transition from sketches and models and technology to do like different projects from the past, let's say, probably like 13 to 14 years. But you see here are a lot of attempts that try to combine technology and the practice of architecture, and this trying to pursue like this Albertian paradigm, or like perfect transition from the digital to the physical. So you see here some projects that I designed and built in the past, trying to look for that, also working in different things. So what I'm trying to get here is this moment where I had the chance to work with a team of people from MIT in 2012. Onur Cicegun, Alexandra Tsami, Sergio Raya, and Carolina Pino, is that I realized that in order to reach the next level and to keep pursuing this goal of trying to integrate technology and design, focusing in this transition from idea to object, I needed to go somewhere else. So this is why I came to MIT in 2013, and I work in this idea of in this process of translation, right? And I identify a couple of problems. For example, the design through black boxes, the creative gap, and the design through the generic, in the transition from idea to model to code to fabrication. And I was advocating for a more exploratory, improvised, situated, embodied action-like type of process for designing. Mostly, like, how would you do it in, for example, when you're cooking, right? When you have like a recipe, but on the other hand, you have the inactive part of cooking, where you have to take into account materials, for example, where something is al dente, or you need more salt, or you need to see when the onions turn transparent when you're cooking. And that's something that happens when you're actually working with materials. So it's not always a perfect transition. And this also has to do a lot with gestures. So this is my thesis project at MIT in 2015, developed 6 years ago, actually. It's a proof of concept about that. How can we not focus on representation like Ivan Sutherland was advocating during the 60s with the sketchpad? He was identifying problems with it, that when you have an advanced parametric system like that, you're focused on creating a structure to represent something, but not actually designing something. So my idea was to create this interactive fabrication system without representation in order to make and design in real time and to bridge or narrow the gap between idea and object. So this is why I was, to do that, basically, I needed to work with human gestures, but also with machine feedback. This is why I created this machine that was embedded with machine learning from 6 years ago, where it was like way basic than what we have right now, using TensorFlow, other stuff. So I created this proof of concept where I was doing gesture detection with an algorithm that was adaptive naive-based classifier from Nick Gillian, a musician and researcher. I was playing with these interactive machines, trying to do real-time control through like tangible interaction, for example, or I was using algorithms like A-star or RRT, not to control a machine directly, but modify the environment where the machine was performing in order to get like some unexpected feedback from the machine, trying to reach for a collaborative environment. So this is why I made this machine. Here you see me a couple of years ago testing the machine. It was very successful. And the goal was exactly that, to basically create this interactive real-time fabrication machine. Like a, let's say like a really naive proof of concept using this wire cutter, this 5-axis machine that could rotate and also move to, let's say, end effector with your hands. And what I was pursuing was exactly this. What you see on the left side of the screen are actually two different people trying to make a double curved surface from an image. And the results are completely different because the machine was trained differently from them, by them, and also because the gestures were unique. And on the right side of the screen, you see two people trying to actually make with this machine a cube. And of course, the results are imperfect and completely different, but also very appealing in terms of the shapes that came out. And again, they were product of like a unique way of making stuff. So I continue working on this. I'm gonna go, and then I apply this in the academic environment using a methodology that was, it's called discrete heuristic, but it was published in CAD Futures 2017. I did a couple of workshops about interactive machines, such as this one in the University of Hong Kong. And then I tried to apply or reach the next level when I came to my PhD, try to see how can we use modern techniques in order to enable not real-time interaction, but real-time collaboration with machines, with the goal of translating this type of intelligence to, for example, on-site robotics, right? To use robotics on-site for example, construction. Not only for like creative purposes that I'm still very interested in that, but also how can we really basically get rid of only the offline programming paradigm and take it to on-site, responding to the ever-changing conditions of, for example, a construction site. So what you see here is the product of implementing something that is called intelligent robot manipulation, where you don't program a robot, but basically you just set the conditions for the robot to find its own trajectory of way of making things. So what I program here is just determining point A, basically pick the block and then just leave it in the shelf. And then through a couple of algorithms using, for example, bidirectional RRT and others, the machine calculate angular velocities, torques, and all the things that need to do in order to perform. So what I did in the workshop was trying to teach students how to use, for example, reinforcement learning to teach a robot to perform certain tasks, not use direct programming on this robot. So what you see here is the robot on the right it was already trained, but now from the movement of that robot, I'm training the robot on the other side, and it's learning how to move to the other robot. The idea is to enable this type of workflows that you can basically use also like deep perception systems in order to enable this. I don't know if I can advance the video, it doesn't allow me. You can control robot and create this type of feedback where you can teach robot in real time in order to perform some task. So what you see here is a way of generating KRL code, basically like KUKA robotic language in real time, translating this to Grasshopper. And in order to have a little bit of this imperfection, but also like a way to respond in real time about ever-changing conditions of something. So my goal right now, I'm trying to work in this project that I did with Molly Mason and Alejandro Gracia from MIT and Harvard, respectively, about like implementing this into like what I call like radical ceramics. How can we enable these procedures to like the field of robotics and to do some things or take, for example, like clay fabrication to another level. And with this, I'm going to finish. Also, I've been pursuing other type of procedures focused on fabrication in order to how can you use, for example, machine and deep learning to create like a collaborative design environment as well. So in this case, with minimal input, this is a project that I developed with Renaud and I, building technology PhD here at MIT, about how can you with minimal input sketch something and let the machine basically collaborate in the 3D modeling and to give you a 3D model in real time. So what you see here is a watertight 3D model that you can 3D print immediately. And also enabling deep perception systems. So for example, here I'm doing like object detection and also pose detection in real time using depth sensors cameras that can basically enable you to actually control and train robots in real time. So yeah, and other projects that I'm not going to show because I'm out of time. So thank you very much. If you have any questions, please feel free to email me. And yep, thank you very much.
Yeah, thank you. Thanks for your time and contributions. I would like to ask Professor Neil for an announcement, if you would like.
Oh, thank you, Ahmed. My apologies for my voice. I've got a cold. Yes, this week on the 1st of October is the deadline for the submissions for the new 2-year non-residential Doctor of Design degree at Florida International University, FIU. If you have any questions, find my email address online and I can respond to you. But it's a radically new program. It's non-residential. We meet up just 2 short periods, 2 9-day periods a year, and there's a possibility of going 100% online. So email me if any questions. But October the 1st is the deadline for submissions. It starts in January 2021. Thanks. Thank you, Ahmed. Thank you.
Thanks for sharing. Yeah, thank you. I would like to ask Paradeep to start his presentation. If you'd like, share your screen. Yes, go on.
Thanks, Ahmed. Are you guys able to hear me? Hello?
Yes, yes.
Yeah, perfect. So good morning, good afternoon, and good evening to everyone around the world who's actually viewing this presentation. Thank you so much, Digital Futures, for the opportunity and creating such a wonderful platform for all of us to share our works and discuss and participate in workshops and so. Sushant and myself actually co-hosted a workshop, Robotic Fabrication. A little bit of Sushant. Just a minute. I hope it's working. Yeah. A short intro of Sushant. He leads the RATLab studio in India, New Delhi, and independently founded RATLab Education, which has established India's 6-month hybrid program on computational design through Smart Labs program. Sushant and myself co-founded RATLab in 2012 and conducted this workshop and demonstrated a collaborative workflow Sushant took the role of the designer and myself as a roboteer. I've been working with robots over the last 7 years, so I'm going to show one of the key projects which I've been associated with. The last 7 years, I've been working with various organizations, and which include RoboFold, ArcUnion China, Architectural Station UK, Individualized Production Germany, and UCL. I'm currently a teaching fellow in numerical manufacturing at the UCL. Through the So the project which I'm going to show today is the Wucheban project. The project actually explains the potentials and constraints of a robot, how they could be implemented in a design. So I'm just going to show one project today because of the time limit, and I think I'll go into a little bit detail how those constraints actually helped in terms of influencing the design. So I was appointed as a robotics developer at the Architecture Association Hook Park campus, which is located in Dorset. It's off campus, not in London, but it's on the southwest of England. And I got appointed by the Knowledge Transfer Partnership Program. The design program was directed by Emmanuel Cruz and Martin Self. Emmanuel is currently the director of design for manufacturing at the Bartlett. The project demonstrates how robotic constraints influences the design process, like I mentioned, and why this project without a robot would be insanely difficult, and how the robot actually plays an integral part of this process. The Wucheban project was developed by the students of a Design and Make Masters program, which is located on campus. And this was the first robotic construction project at the Architecture Association at that scale. Um, the project is an arching volumetric truss made up of 20 distinct beech forks and was realized through the combination of 3D scanning, parametric modeling, and robotic fabrication. Assembled on site, the truss spans about 25 meters from front to back, 10 meters from side to side, and about 8.5 meters at its peak. The intention was to develop a system to exploit the inherited forms of timber structurally, and the design was inspired by the performance of naturally occurring branching forks in trees. Most wood used in the construction industry are in the form of sawn timber for building complex structures. So we came to an idea that how we could skip a step before processing and harnessing the structural strength by using its tree in its inherent form. The final basic structure of the truss, or the geometry of the truss, was developed, and on this truss simple structure, the forks would be oriented. So the hunt began for the forks in wanting to use the real fork geometry for digital development. The trees around the forest were photographed. Algorithm was developed to correct the image, the parallax of the image captured by the camera, and outline of the fork was redrawn. Over the course of about a week, about 204 folks were surveyed around Hook Park. And because it's a forest, it's about a 150-hectare forest. We were able to scan a lot of trees. And a script was actually developed in Grasshopper, which allowed us to show which forks could be evaluated and mapped simultaneously. Considering the angles of opening, relative diameters and proximity, some of the forks were actually nulled out or were culled, and we had to use only a certain amount of forks for its diameter and its opening angles and its geometry. And then we went around the forest harvesting forks, which is about 25 forks we harvested from the Hook Park, and they were brought onto site. Each fork was approximately about 5 meters. It was over 5 meters in length and weighing more than half a ton. The next part was to actually get these forks into the digital environment. Photogrammetry was chosen as a tool to scan this forks. This image shows you some sense of how software begins to construct a model from about 60 images. Using photogrammetry, the downside was the inaccuracy was about 10 to 15 or 15 to 20 millimeters. To address these issues, the geometry was scanned along with 3 points. 3 points, we used a jig for calibrating these 3 points. So how did these 3 points actually help us? These 3 points frame the reference system for the forks. To position such a complex geometry in 3-dimensional space, we needed a reference system. So irrespective of the inaccuracies of the scanning, the connections in between the forks were developed using the reference system and not the scan geometry. These 3 points served as a reference system throughout the process. From the time we scan, we use them in the robot cell, and then we assemble on site. It's all, we use the 3 points reference system. So here's a short video of how we used an evolutionary algorithm to actually get the right position of the forks. We used to manipulate the position in length as well as the orientation on the existing rough geometry, and then we would start making connections. So following the final fork volume, we created some connections. The connections on the left is the manually done ones, and the ones on the right is done by the robot. The depth of the cutter was about maximum of 150 mm. We used the milling router bit, which was mounted onto the robot as an end effector. And the constraint of the tool is when it actually informs the design of the joinery. So these kind of small constraints were actually influencing the design process. If the connection had to be made manually, we need several jigs, and considering the number of forks we had and the number of connections on each fork we had, the digital approach was completely necessary, and that's where using a robot was absolutely essential. The connections were not complex to manufacture, but the stock material, in this case, the forks, was very difficult to man or work with. Hence, using robots to mill was the only efficient way to develop the connections of the truss. But there was a problem. The size of the forks was an average of 5 meters. The maximum reach of the robot was like 1.75 meters. Hence, the size of the stock material, which is the forks, grow outside the working envelope of the robot. Especially while fabricating complex angles, the robot's reachability was the biggest issue. We developed a cost-effective solution. Charlie, our workshop manager at Architecture Association Hook Park campus, came up with an ingenious solution of using a simple manual trolley which can be moved along a rail. Normally, this kind of project would have been using a huge gantry system, which would cost hundreds of thousands of pounds. But I think the entire cost of Charlie's kit was less than 500 pounds. So one of the most cost-effective solution and an ingenious solution which came up for this project. To know the exact position of the forks, again, the 3-point reference system was actually taken, and the 3 points was pre-calibrated, or the jig was pre-calibrated. But the biggest challenge was for me to push these forks from over the rail for every joinery. So we came up with optimization algorithm, so that the minimum amount of movement of the trolley, we could achieve maximum reachability for fabricating the joinery. While fabricating each fork was precisely fabricated using the robot. Their sheer size required manual assembly. In order to facilitate this process, a large jig was conceived. About 18 sheets were actually a number of sheets and vertical supports were allowed with each component to be positioned before they were completed, and each fork was had about 3 points, again preserving the reference system. Finally, the forks were assembled on site using a crane. It's the sheer size and scale. I think this project wouldn't have been possible with these technologies, and that's where we could use the potential of the robot to its fullest. It's not only used as a prototyping tool, but as a process tool too. Here's a short video of how it materially informs design process, but I think we are out of time, so I'm just going to show about the workshop a little bit. The workshop introduced the methodology of using robotic technology in creative fields through robotic 3D printing process. So we wanted to start, it was just an introduction workshop to robotics, and we wanted to explain the concepts of kinematics, how a tool is mounted onto the robot, and how they actually are developed using a process, robotic process. And here's a short video of the workshop.
RatLab conducted an online workshop on robotic fabrication at the Digital Futures 2020, led by Pradeep Devardas, teaching fellow at the Bartlett School of Architecture, and Sushant Verma, co-founder of RatLab. The workshop was attended by over 25 participants from around the world. The workshop introduced the methodology of using robotic technology in creative fields through robotic 3D printing process. The aim of the workshop was to enable participants to develop robotic processes by realizing the potentials and constraints of a robot. The participants were first introduced to the fundamentals of robotics through simple exercises which explained kinematics of a robot, coordinate systems, and how to develop a process. The process illustrates how to develop a toolpath and generate a program using a QKR6 robot and 3D printing extruder to build simple forms. Although the tutorial uses a specific tool and robot, the concept can always be translated into other processes. Next, the 3D printing designs are developed by the participants, which are controlled by robot constraints through live simulations and interactive exercises, which demonstrates an informed design process. The workshop resulted in the participants developing and realizing their own designs within the process constraints.
So that's about it. Cool. Thank you so much, guys.
Thanks for sharing that project and workshop outcomes. That was amazing. I love it so much. I have questions, and I believe our audience as well have questions. So please write your questions on and thoughts on YouTube and our Discord channel. We are happy to discuss these after our presentations. Let's move to our next presentation by Nigar. Would you like to share your screen? Yes.
Yes. Give us a second. Okay. Okay. Hi, everyone. My name is Negar Kalantar, Associate Professor of Architecture Division at California College of the Art and co-director of the CCA Digital Craft Lab. Today, I want to talk briefly about our workshop that we had during the Digital Future event this summer, and our concentration. Our team consists of 4 people, me, myself, and Nathan King from Virginia Tech Autodesk, Jason Kelly Johnson from CCA, Mehdi Farag Bakhsh from Texas A&M. And here briefly, I want to talk about, we had 5 different modules. In the morning, it was a 3-day workshop. We covered the theoretical aspect of clay and the history of the clay and how the digital clay can address in the future of, 3D printing construction. And because of the feedback that we had from our survey before starting the workshop, we had 120 applicants that started, but 80 of them, got through this 3 days intense workshop, and we had it from 15 different countries. From my side, we went through the workflow of based on the background of their participant, we adjusted our workshop in a way that we covered all the basics of knowing how to design for robotic, how to generate the G-code, how to communicate, and talking about end effector, and finally about tool pathing, and how in a mesoscale we can change the tool pathing for strengthening the layers between layers. But I want to thank Digital Future for giving this opportunity as an instructor to work with the, interesting participants that I think it never can be happen in another situation. And I saw it was one of the highlights of my summer that I had this chance of, teaching this wide range of people, talented and interested in the topic. But I want to go back a little and talk about what is my research interest. And my major question is, what are the segments of research that needs to be done if we want to go for robotic 3D printing and construction? And I could categorize them in 4 different sections. We need to do the material studies, hardware, software, design, and the logistics. And one by one, I'll pick one project that I was been involved and talk about them. In the material side, from 2018, I was part of a research grant that granted by Texas A&M president of the university on investigating what's going to be the future sustainable material for 3D printing construction. And our goal was, how to not use cement-based paste for 3D printing, because we know that this is harmful for the nature. And now this is the time that if you want to switch to another material, now that we are switching to another construction method, what's going to be the material that is proper for this process as well. So we are developed a type of clay that has some biobinder inside it, the thing that termite or a lot of animal does, for strengthening the bonding between the materials. And so the result come out really interesting. If you're interested, we published a lot of paper, and it's featured by BBC Guardian 2 weeks ago. So the next section is a hardware and software, and I think that a lot of us are trying to address these aspects. And this is the project that I've done with ETH and was presented as a one workshop in RobArch. And our goal was, while we are 3D printing with the robot, we are dealing with two different controllers. One is coming from the extruders, one coming from the robot system. And these two communicating and getting feedback from real time and communicating back with these two processes is a little challenging. The other thing is, most of the tool passing happens for perfect material. You're not changing the property of material during the printing. Although we are dealing with if we are dealing with the clay or cement, there are a lot of changing in the process of printing. For example, material can shrink. You can have a failure in one layer, and how you can predict that one and change the Z action of your printing while you are printing. So this was the way that we dealt with it. We had a 1D scanner on the head of the robot that could read the next step of the printing. So we didn't have any information of the Z in the process. We could get any substrate printing on it. And this can be really helpful for example, if you want to repair a concrete surfaces and you don't want to scan the surface, you can just send the robot there and by scanning and getting the feedback real time, and you can repair the surfaces. The last part that I want to talk about is a design. And I think that we are all designers, and we think that how we can design for these new tools and technology, and not forcing the technology to accept what we have designed for other processes. And the main question that I have is why we are doing, why everybody is trying to make a larger robots or gantry system to print an empty box that is, our building. And the other one is there any way that we can use the smaller 3D printers for printing large robot, and how we can use the 6-axis of robot to 3D print without the scaffolding, and learning from the old masonry processes, the way that they handle complex shapes only by changing the angle of adding the material. So the first project is a print in print, is an ongoing project that, how we can develop the geometry that could be compact and stackable in a really compact form. And instead of having a large robot to print a large volume, how you can make the segments of the volume inside each other and print it. The principle is the inner shell is somehow coming from the outer shell. The outer shell of the second piece is the inner shell of the first piece. So it's more look like you generate a surface, the inner shell of your structure could be generated through the outer shell. And it can be possible almost to do any surfaces or volume out of these processes. It's more about how you slice it and how you thickening the volume. And it doesn't need to be only one volume. It could be a complex, geometry of convex and concave, and has, can be produced with the same system. Or you can segment your volume in vertical and, do the convex and concave in a different patch. And it's not only for the closed volume, it can do any type of freeform surfaces. And the good point about this one is you can print over each other. Each segment could be the scaffold of the next piece. For example, here you can see instead of printing the arch, you can print this stack of the material and deassemble it and assemble it in the final form. Or for making this curvature, you can have it in a vertical position and then reassemble it in the final form. And it was it started from 2018 that we had this goal to design an arch system with the interlocking, without no bonding or and coming from out of one piece of block of material. And our goal was how we use the tools in the full capacity with no waste in the material, and all the locking system, generated by the capacity of, the robot angles. And then we expanded these techniques to different surfaces, and now we are, confident that we can use this for almost any free-form structure. And the last one, and the good point of this, you can always compact your structure and ship it to someplace else, and disassembling and assembling can be really easy. The last project is the continuation of what we did in the workshop, and this is the research that Mehdi is doing at Texas A&M, and he's working on how we can change the property of layering and tool passing during the printing to have a better bonding between the layer. And for addressing that one, we're thinking about what are the segments or parameters of the printing that we can play with that. And all of these patterns is, it was just a straight line, but it was just changing the, the flow of the material, delay, adding the delay on some points. And with this, we got to generate really different sort of composition of the material. And the next step is 3D scanning them and seeing that structurally how much the bonding between layers is getting better. And this is, as I mentioned, is a PhD research at Texas A&M by Mehdi that we have a presentation in Arcadia if you're interested in. The other segment of this is how we can break a geometry to the components that can be printed without the scaffold, and each piece, each two piece or one piece could be somehow works as a scaffold of the next piece. Exactly how the dome structure were constructed in over centuries. So these are, some of that I mentioned about the Arcadia. If you're interested about the recent project, you can attend our session in Arcadia. And thank you for this opportunity for sharing my research with you. You can, have question and, during the question and answer. Thank you so much.
Thanks for sharing. That was very interesting.
Thank you.
For me. And
Thank you, Anna.
I think for everyone. Yeah. Veronica from Fab House will be our next presenter. So please, Veronica, yes, move on.
Yes, hi, thank you. I will share my screen. Just a second. Can you see the slide there?
Yes.
Yes. Okay. Okay, so thank you very much for this invitation. I think Digital Futures is a fantastic platform to broadcast the digital work, the research among architects. I am Veronica Arcos. I am a Chilean architect, and I spend half of my time in research in the academic field and also in my professional practice. I studied architecture in Chile at the Central University and did my master's studies at the Verlaine Institute in Rotterdam. After I came back to Chile, I started my professional practice, and I have always been interested in the intersection between local and traditional constructive systems together with the computational design thinking. So I think from a country like Chile, what we can contribute to the knowledge is exactly that, our traditional systems, but thought in a different way. What I will present today is the work that I've been doing the last 1.5 years This started with an invitation from the Bio University in Concepcion in the south of Chile. They bought a robot arm and a concrete extruder, and they invited me to have some experiences to test this new technology. So these initial tests yield fundamental results of additive manufacturing technology, from where you can start to build a catalog of constraints informed by the geometric possibilities of 3D printing. This is the robot. This is a test with clay that we did in August last year. And in this video, you can see that the form is not strong enough to remain stable during the printing process. When reaching a certain height with the impression cord, the piece does not support its own weight and collapses. These are the first tests that we did the first time I was there. In the second iteration, the concept of grind strength or structural stability of the shape is taken into account while the mixture is still humid. So when you have like more, by maintaining smaller distances between their contact points, it results in a resistant form more suitable for this construction technique. So, of course, the inner cord or the contact points to support the form while it's humid is something fundamental for this technology. These are the results of that afternoon. Well, after the lockdown, when the pandemic started, all the fab labs in Chile and the universities were closed. So I started doing this 3D printing test with porcelain with the Universidad del Desarrollo, the design faculty, with a small 3D printer. So I started doing these scale models, and because of it was the only tool that I had available during these months. In these models, we seek to give expression to the surface by incorporating three-dimensional patterns. Several iterations are made until a successful combination is reached between scale of the pattern, diameter of the cord, percentage of displacement with respect to the lower extruded cord, surface thickness, and total height of the model. So it's all of these parameters are put together and to have like a stable form that is expressive and still stable while it's humid. These patterns can be thought of as customized facades that provide both an ornamental appearance and a bioclimatic performance to the building. So I was thinking of this, how to give a new identity or a customized facades. I don't know if you design a cluster of 100 housing units, you can have 100 different patterns in order to have like a more a sense of appropriation from the inhabitants. And also, not only this ornamental, I think when in architecture or in design, when you have more than one function for a design decision, like aesthetic and technical issues, it becomes more stronger. This is one video showing these tests. This was done like 2 months ago. And now, very recently, a few weeks ago, I was called by the Ministry of Housing and Urbanism, the Chilean ministry, because they are very interested in the 3D printing industry. and they want to start helping this research in the country in order to transfer this knowledge to the industry. So we are about to sign an agreement to finance a series of prototypes, of architectural prototypes, in the next 12 months. So we are thinking of doing prototyping discrete pieces like columns or panels or walls or beams eventually to and this research, the results will be published in a book at the end of the next year, and also exhibited in the most important cultural center of Santiago. So my aim is always to contribute to the knowledge, and also to not to stay only in the academic field, but to how to push it to the real practice. Well, in the last Digital Futures, Tomás Vivanco invited me to give a workshop with him. He will show some of the material that we did with the students a couple of months ago. These are the scale models that we printed just 2 days ago of the columns that you were seeing before. And well, I'm really looking forward for the labs to open, hopefully at the beginning of October, to start printing in clay and in concrete in a one-to-one scale. So I will finish with this video, and then Tomás can go ahead. Okay, so thank you very much.
You are welcome. Thanks for sharing. Thomas from PUC, Chile. Yeah, would like to start. You are muted, Thomas. Still muted.
Hello everyone.
Unmuted.
Can you see my screen?
Yes.
Yeah, and it's full now. Yeah, well, hello everyone. Yeah, as Veronica was saying, I will introduce the results of the workshop. The first thing to say about the workshop is that working in Latin America in between semesters, students, or the possible students were everyone almost in classes. So we decided to do a low-level workshop, just considering the minimum steps required in order to design and simulate the robotic fabrication of clay 3D printing, considering that in Latin American architecture and design schools, there are a very low use of robotic arms and so forth. So our workshop was based in 4 main steps. We had students with different backgrounds, but also with different technical knowledge. So we didn't want to spend too much time letting the students know or get too much know of the tools. In this case, we work with Grasshopper. So we did very few steps in order to maximize the possibility of form. So the first step was to do a form finding processes. Then we made a resistant form, then textures and patterns. And at the end, we did some fabrication strategies. To begin with the workshop, we started to play with very, very basic forms, but each of these extruded forms were considering some material constraints. This means all the, let's say, the exercises that Veronica was doing before, the idea was included in the design process. So the students will have a very brief and fast, let's say, test or taste of how the materials, in this case, clay, will perform, and which is the relationship in between clay and the final outcome and the geometry. The second step was to once we extruded these forms was to think about the possibility of resistant form considering the weight of the material. So considering weight, this means that we need to, the students need to think about how the geometry can be, let's say, be lighter when it was growing up in the set axis. As first step, then we work with different textures and patterns, and this idea was working with the minimum possibilities of the resistant form and how the resistant form can create a texture and pattern by itself. Again, the idea was to use the minimum amount of code in order to maximize the three-dimensional potential of each form. And then at the end, we did a combination in between the texture and the resistant form with the some fabrication strategies. So we used different plugins for Grasshopper, but also with some students, we teach them how to write their own G-code with a very simple expression in Grasshopper in order to transfer or to personalize their G-codes in order to transfer or to send it to any type of fabrication machines. They only have to change just a few lines of codes in order to control the machines. From these G-codes, we experiment sending to different simulations programs, but also we send it to different robotic arms simulations. So we have a very vast variations of possibilities. Some of the results are these ones. Again, the idea was to, it was a very, very basic workshop, but the idea was to maximize, again, the form and the material expression. But also changing some very few line of codes in the same or within the same definition, we can explore different materials of final outcome possibilities. And then some students worked with applying some external textures, another one was internal, and so forth. So, yep, that's it. Thank you very much.
Thanks, Thomas, for sharing. Our last presentation, but not least, Sina Mustafawi from TU Delft DIA. As we used to say in Arabic, وختامها مسك. Move on, Master Sina, please. Sina, yeah. You are muted.
So hi everyone, great presentations. Today's presentation is titled Hybrid Robotic Matters. I'm Sina Mustafawi from TU Delft and also the Science of Architecture. And I'm also running a practice called Setup Architecture Studio. This lecture is titled Computational Material and Fabrication Intelligence in Robotic Materialization of Architecture or Hybridity. It consists of 3 subsections. I'm going to have a very short introduction to the background. Then I'm going to explain the methodologies through some case studies and projects. And towards the end, I'm going to introduce I'm going to go through the results of the Digital Futures workshops. So what is interesting to me is the way we can translate a very complex production process, such as, for instance, weaving, into a systematic way of basically translating a design into production. So for instance, in this case, you see a loom machine back in 19th century, and also the way we can sort of learn from the craft and also find a way to translate these crafts into production, systematically produce them basically. So, and also it is also striking the way the backbone of computation is somehow connected to the way we sometimes translate production or fabrication into a systemic way of materialization. And also another important factor is the way we can establish basically feedback loop between the output and the input. And of course, when it gets more complex and we deal with more subsystems, the way we sort of map the relations between the subsystems in a complex system is another important factor. But back to the core of the research topics, I think the field of architectural robotics can be divided into two major fields. One is design to robotic production systems, which deals with fabrication, and another field is embedded operational robotic systems. And I see these two fields very much closed. For instance, in this case, where we are sort of customizing the livable space for these creatures, it's about also this customization and basically changing the livable space of these creatures. And also, I'm also coming from a Hyperbody group where we are also looking into basically reconfigurable systems using embedded robotic systems. But what is also important to me is the way we basically establish this direct link between imagination or expression into materialization, which was also addressed in some of previous lectures. So in summary, I think it's about how emerging technologies are transforming the experience and practice of architecture. And of course, if you change these emerging technologies into more specific terms, you can get more accurate answers. So it's also about how we shape our tools and how our tools sort of shape us. And in terms of the goal is to basically bridge the gap between design and construction using computation, automation, and materialization. So the main body of my presentation is consisted of 5 sub-chapters or sub-parts. The first 3 parts is about the materialization model that I introduced, in which I address porosity, hybridity, and assembly as the new materials to work with when it comes to robotic materialization. And then I move towards more recent projects, which I discussed interdisciplinarity and a bit of my practice, and also will have some conclusion about the materialization model. So when it comes to porosity, I would like to refer to these projects, which was about robotic 3D printing of porous ceramic structures. I see that many of the cases sort of address this ceramic printing, but what was important to us in this particular project was basically establishing the link between digital and physical, and also introduce a way to, on one hand, of course, customize the production setup, but also establish link between different scales in architectural design materialization, which somehow connects to another previous project that I did, which was about translating basically the discrete result of, in this case, topology optimization into sort of infinite or continuous result on the right, where we extract sort of vector-based geometry or continuous geometry out of this discrete system, which again goes back to this idea of systemic thinking in design, which goes beyond the tool that we are using. And it's also about the way, for instance, in some cases, we can bring new disciplines, in this case, image processing, into the palette of architectural design process in order to translate this discrete result into continuous results. Then back to the robotic 3D printing project, what was important for us in this case was to basically translate this discrete result into a continuous toolpath, while we were keeping basically the material architecture or the very structurality of the design. The next topic is hybridity. And hybridity to me refers to, on one hand, hybridization of production processes, but also refers to hybrid materiality. When it comes to hybridization of basically production processes, we mean the way we can combine different production techniques in order to be able to basically inform the design. For instance, in this case, combining hot wire cutting and milling is sort of informing the design, and also it results into sort of not only an efficiency in the production process, but also a way of looking into the geometry and rationalizing it, but it also leads to a new aesthetic. Back to the topic of hybrid materiality or multi-materiality, I'm going to go through 3 projects quickly. One, this is this project of hybrid Cork, where we are removing the material following a specific pattern, which results into sort of flexibility and bendability of material, which then results in translating basically this 2D rigid structure into a flexible 3-dimensional object. Or in this case, where we were looking into the way we can rethink about the way we work with molds. First, we were using one material, and then in the next iteration, we were looking into the way, for instance, we can use 4 pieces instead of 2. And then by this, we were able to basically keep some of the part of the molds inside, sort of intertwined with the structure, and this created this hybrid material system. In another case, where we are also combining 2 different methods of additive and subtractive and additive manufacturing processes, we are looking into the way we can use the adhesive, basically, qualities of the material, such as silicon, and then addressing this really high resolution detail in such a way that also help the way we sort of deposit the material. And this is sort of summarized in this project, which we are also exhibited in NAI and also presented in RoboArc, where we are basically depositing the material on a chair where we sort of sit in order to introduce some sort of flexibility. And then you see how this combination of different and integration of different fabrication routines sort of inform the design, but also result into a new level of detail and aesthetic. Again, this systemic thinking, and then also informing the tooling process according to the way, for instance, we can avoid self intersection or collision with the object. And then, for instance, in this case, we also develop a tool path where it was about a continuous tool path in such a way that we make sure that we run from one cell to another cell instead of bumping to basically colliding with the object. The third subject is assembly. It's somehow also was addressed in another presentation, which is about like how we can go beyond the production setup space of a specific tool that we are using, which to me is a very interesting and challenging task. And I would say when it comes to assembly, one thing is about the sequence of assembly. For instance, in this case, we are using dry assembly in such a way that we make sure that at any given point during the assembly, the structure is stable. Or in this case, we are trying to address assembly using reciprocal structures, and then introducing a way of basically connecting the elements in a free-form reciprocal structures. And in this case, you see how the method is sort of developed, and the result of this project is also presented in a recently published essay in ICADI. So to sort of conclude, and sorry. I think I have a problem with the
Yeah, it's fine. Yes, we can see.
I think I need to close. Excuse me.
Okay. Should we wait, or we can have a few discussions until Sina is back? Do you have a recommendation, Professor Neil?
I think I'm ready to go.
Okay. Just move on.
Do you see my screen?
Yes.
Okay. So back to this idea of interdisciplinarity, I'm gonna go through some of the projects where we're basically collaborating with other disciplines. So I think the idea of going beyond the scope of basically architectural design would allow us to think about new tectonic and new materials. For instance, in this case, we were collaborating with design students and architecture students. We were focusing on the way, for instance, we can customize a material, in this case, bioplastic for robotic production. And
sorry, Sina, I can see the screen. Would you make sure that you shared?
You can see the screen.
Yeah, I can see.
Okay.
Okay, that's great. Okay, move on.
Okay. So we were looking into different methods of production, but at the same time also customizing the material for that very specific method of production. And then this results into, for instance, cutting the material or adding, for instance, different additive materials, in this case, self-illuminative material to the palette. Another project which was about, again, basically crossing the discipline, it was this project sponsored by Audi, where we were again collaborating between architecture students of mine and design students of Manuel Kretzer. So the idea was to basically design a new car and produce it in a one-to-one scale, but also integrate basically different sensors and actuators, in this case, smart glasses or smart lighting into the whole palette. So I'm gonna skip through the video in order to be able to have more time towards the end for the workshop. Or in another case, we were looking into basically this idea of data-driven materialization, where we were looking into the way, for instance, we translate our emotions into matter. For instance, in this case, translate dancing into robotic painting, or translate basically our movement in the city to the robotic painting. Or in another case, we were looking to the way we can, for instance, translate the way we listen to a music into a matter. Or in this case, we were looking into the way, for instance, we can translate the way we interpret seeing a movie, and then this results into different, basically, systems for materialization. So I would argue that data is the material in different scales, and somehow the result of this materialization model is summarized in this book chapter, written in this really nice book by Mahesh and Andrew. And to bridge a bit more towards practice, I think many are familiar with this example when it comes to rationalizing basically complex geometries. But I would like to also add another example from my hometown, again done by Arup, which it's really interesting to me the way this idea of rationalization does not necessarily mean simplification. For instance, in this case, you see this curve is a curve which is suggested by the architect, while this curve, which is visually more complex but mathematically more simple, because the left curve is consisted of two straight curves and one basically curved curve, is in terms of visually is more maybe simple, but it's not necessarily rational. So I would like to argue that when it comes to materialization, rationalization is not necessarily simplification. And another example that I can sort of bring to the table from my own practice is this example that I recently finished. It's about like how we can, for instance, in this case, combine stonecraft with CNC produced metal, basically boxes, which are more accurate. And then this combination of basically different tolerances, I think in hybrid system is really interesting, and I would say important to consider. And in terms of sort of critiques that I sort of received for this project, sometimes I think that maybe this is somehow rooted back to where I come from, but or for instance, in this case, you see this example by an architect in Cologne. So you see some sort of visual similarities, but I really liked this one because they are sort of criticizing the project in a way that is very digital to me. So they call this Windows 97, which to a certain extent maybe it's true, because this is one of the first video games that I played, which sort of basically translates this projectile motion of Galileo into a very simple game. And I would argue that the next generation, when it comes to gaming and the way we see basically digital space and virtual space, is going to and is sort of changing the way we perceive and design architecture. So to summarize some conclusions, on one hand, it's about like bridging the gap between production space, design space, and material space. And this bridge, when it comes to architectural education, can be taken in a very creative way and integrated into the architectural, basically, pedagogy. And at the same time, it's very much about how we sort of think about a production as a system. It almost become like a kind of a surgery. And when it comes to topology or geometry, it's about the way we can think of basically architectural objects as families of objects, and this sort of inform the production and material space at the same time. The next conclusion can be about the way the variation and performance can work together. So obviously variation can lead into performative solutions, but the question is how we can sort of integrate different data sets together in order to inform our design. And of course, when it comes to more, let's say, quantitative examples such as structures, this might be more straightforward. For instance, in this case, forming the metal to be able to achieve a higher, basically, strengths, while in the cases that we are dealing with more qualitative or architectural objectives, this might have a different, this might need a different approach. Another conclusion is about like the way we see finite and infinite. I think this idea of discretization and discrete architecture is sort of misunderstood in architectural design, because when it comes to computation, discrete is a given fact. So I don't understand why do we need to sort of see the whole architecture as a discrete phenomena, while this is something sort of given. And another interesting aspect is the way we can work with volume. So obviously, when it comes to additive manufacturing, this volumetric thinking is sort of, again, given and interesting, but I would argue that like when it comes to subtractive manufacturing, we can still think of what we can get through porosity inside the material system. And when it comes to assembly, I would say, obviously, this idea of sort of segregating or separating the architectural elements, I think is questionable. And I think we can work with this idea of components in architecture. So to summarize, I think the materialization model can be a multi-scale, multi-mode, and multi-material system where we can think of new solutions rather than providing basically automated solutions for architectural systems which might not be necessarily efficient. And last but not least, when I want to, if I want to move towards the workshop, I think this idea of master and protege is also changing. We had a very interesting panel discussion on the future of education. I barely find myself giving lecture, and before Corona time, I think this collaborative effort between sort of master and protege was something really interesting, and somehow maybe Digital Future is initiatives like Digital Future can sort of fill this vacuum. And sort of conclude with the result of the workshop. We had almost 60 entries where we had this luxury to choose 15 of them. And this workshop was basically, again, on this idea of hybridity or hybrid materiality. And since we didn't have any access to robotic fabrication workshops neither in Germany or Netherlands, we were trying to basically focus on computational design side of hybrid materiality. And then the initial input which we sort of created or provided for the students was these 4 different types of hybrid systems. And it was amazing that after only 1 week, we were able to exhibit our results in Spain in this castle, and of course virtually. And the workshop was also joined by a former student of mine who is an artist. She's Arisa Wan. She's also collaborating with ESA European Space Agency. And it was also interesting how in this short time, and also the fact that we are sort of missing this one-to-one interaction, different mediums of design, including sketching and also computational design, and also exchanges between different students from all over the world can sort of compensate the lack of access to fabrication facilities. As you can see here are some of the results in this castle, which the link to the virtual exhibition is also available. I'm going to share it later to the chat box. And it was also really interesting to see that by having access to multiple fabrication labs in Germany and Netherlands, we were able to also not only design these hybrid systems digitally, but also be able to prototype in a one-to-one scale some part of the design that we have sort of developed in 1 week. And yeah, with this, I would like to conclude my presentation. Thank you very much. I'm sorry for the interruptions.
Thanks, that was amazing. Yeah. Thanks for the presentations. I'm so excited and have a lot of questions. I would like to start with asking Nigar. Actually, I'm working nowadays on a research project in between. Let's say the idea is between Nigar and Veronica and Thomas. It is something in between. But I'll start by asking Nigar. Fabrication methodology and technique is very interesting. My question is, if you are using an adjustable mold, that would help or not? You are yeah.
Yes. Are you talking about adjustable mold in the
adjustable
mold in general?
Yeah. You were having a mold and then doing the 3D printed regarding the third dimension of these tiles you are printing on. So if it is an adjustable mold.
Yes, I'm a good point in for the Rope Arch 2018, we had this idea because in another research we were developing how we can have an adjustable mold without throwing out the previous mold, and how we can design it. And our proposal was using that adjustable mold for the substrate and 3D print on top of that. They said that it's very complex for the 3 days workshop, so we removed that part of the research. But yes, I think that one of the aspect that we can think about it is how we can use the adjustable mold for 3D printing rather than having really complex scaffolding system. And it's gonna, there is, good and bad part about this. You have to keep it on the, tray till it gets dry. It may, delay the process of real construction, all of those things. But yes, I think it's a nice topic to think about it.
Okay, so if it is okay, do you have a vision regarding this? Do you have a vision? You were printing these complex tiles on the mold. If it is movable, are you going to do it while moving, or?
Oh no. We adjusted in an you have your geometry. You adjust these jigs, and you get yes, and you do it. Yeah, it's completely another research that how you can design a substrate that could do all these different forms and be adjustable and all of those things. I think that's another study or another track. But I think combination of these two can be very helpful thinking about a real construction for the complex geometry.
Okay. The research was about printing a discrete element on this question is for Veronica and Thomas also to join. The research was about printing a discrete element on that adjustable mold. So and I'm working nowadays on developing that discrete element using AI system. Do you have any concern or advice regarding the printability of these shapes and forms the discrete element when it is assembled together and so on. I know it will be very complicated, as Nigar just said, printing on an adjustable mold and then using these discrete elements to be assembled together for a final object. Do you have any advice regarding the printability of these discrete elements?
I would say that something interesting that can be done, and it's on the line of what Negar is doing with the molds, but in a different way, in a more simple way, is to print it in a different orientation. For example, if you want to print a roof that doesn't support traction because there's no steel inside, no metal, you can print something that works to the compression while it's printed, and then you can put it, change the orientation once is dry, as Negar was saying. I think that is one of the biggest challenges, especially in Chile. We are one of the most we have the biggest earthquakes on the planet. So the normative for the structural design is very rigid here. So I think that if we are able to print eliminating the traction, that's like an achievement that can be used either in discrete pieces or in a whole construction.
Okay, thank you. Yeah, okay. I have a lot of questions. If anyone would like to join to share the space.
Yeah, I would like to ask a question. So I think all of you fantastic projects, and personally, I'm really happy to see the projects really working with new approaches to material, sense, and form. And many of you are challenging pre-existing notions of standardization, mass production, and architectural elements. I mean, it was really clear for me in Sina's presentation, especially. And you kind of show a more holistic approach to systems of design and building. And so my question is, because I've been, hearing a lot during this crisis, discussions about the kind of current crisis, and that we might need redefinitions of economic models and approaches to environment and how we deal with that in the future. And I'm just wondering if you guys think that your approach to architecture can help with that, because it's thinking very differently. So I just thought, I know it's a very general question, but that's something really interests me. So do you think your projects can help along the way of redefining economic structures in our current system of thinking about architecture?
Maybe I can take that. I think that's a very relevant and valid point, and somehow maybe I can go back to what Philippe Morel the last time in his presentation was mentioning, that design research is like design experimentation plus sort of business or entrepreneurship, right? So and I see like many of the students who are graduating, at least from my studios, are sort of graduate with this mentality that they can also, for instance, initiate startups and sort of push the industry to adapt and adjust itself to these new ways of thinking and production. So I think this is one way to look at it, how this is sort of influencing the larger scale. And I think, and when it comes to like sort of justifying or evaluating the results of, for instance, a clay brick which is robotically produced and it's more porous or it's more efficient, so it's less material intensive, or so it's basically it has less embodied energy. And if someone asks whether this brick is more sustainable than a normal brick, maybe in today's world because the infrastructure in the industry is not necessarily ready to take advanced production of a brick using robotic production. Maybe the traditional brick is at the end of the day more sustainable, although it's a very basically if we produce it with let's say conventional methods of production, a brick can also be very resource intensive. So I think one thing is about the time and how we can bridge the gap between this academic experimental research and practice in a long run.
Okay, I mean, yeah, I see a lot of potential. Sorry,
Yes,
sorry, Ahmed, go.
Regarding this current financial crisis, I believe Paradeep has a point of using the trees as it is a rough material in his construction techniques. Do you have a reflection?
I think ours is a one-off project. I'm not sure if it could be replicated in terms of its scale and the amount of complexity, but definitely, it is definitely. The thing is, I still have my own skepticism in terms of taking onto site, because most of the projects which we have demonstrated today is more on fabrication level. It's not an assembly level. The thing is, on-site construction, it's still a question mark, unless like you're working with Hadrian X by Fast Built Robotics, or you're working with Built Robotics, which is a big little robot. They are the ones which has been taken on site. I think what we are actually trying to address here is how does these tools influence the design process itself, and how does the change going to be in architecture? I think that's our main focus. I mean, I definitely, I'm not speaking for behalf of everyone here, but at least I do speak on myself that our focus has been how does this tools exploit the language of architecture, or how they change the language of architecture.
Yeah. Okay, I have a comment too, because I want to come back to this idea of efficiency that mentioned Sina, because I have several discussions with, for example, Mario Carpo, and some ideas that I would like to demystify about the idea of that in a way. I mean, we have Anil here, which is a kind of expert on Alberti, but anyway, I'm going to make my mistakes, but maybe I would like to think about this idea, how we can bring form the way we design with the construction process, because in Alberti we have like this division between the idea of design and then the idea of the building, and in a way is like a kind of fail when the construction is not a reproduction or a copy of the previous design. So I would like to play a little bit with these two words, which is fall, that most of the structures that Veronica showed were falling in a way. So she was like pushing to an extreme matter to this idea of failure, what I consider really interesting. And at the same time that fail and falling can be related in a way, because I mean, we are falling all the time. No, with our gravity, we are falling all the time. We have this attraction to the center of the earth. So we are falling. And at the same time, we are failing all the time. And that's the way we learn. And we are talking about learning all the time. We are talking about education, how we can democratize this idea of a digital future, like as a platform. And I think that we need to pay attention to the idea of error or to the idea of fail, not as something negative, to push it to something interesting to continue working. So I want to make this question, although with all these maybe more abstract ideas, but I want to make this question. What do you think? I mean, maybe the question could be directed to Sina or to Diego, but about this idea of over control. I mean, this over controlling scene that it seems to be in a way dominating the field. No, this idea of, like, for example, I think it's this. We were talking, for example, with Saha Code about the idea of pre-simulation of all the construction plays. So it's like a kind of choreography with machines. It seems that everything is over control. I mean, we have everything over control, but the idea of improvisation, creativity that we have during the construction process it's something important to reinform the process. So that's my question. What do you think about the idea of over control the construction place?
I think that that's a very interesting topic. Actually, that's exactly what I'm trying to pursue, and for my research at my PhD. That how can we, for example, add this idea of error, like making mistakes. Actually, there is a paper that I published last year about it on a more theoretical level. Because what we see now, and you mentioned Alberti, and that happened historically, like every time that there was a revolution in terms of technology and tools that architects use, separated us more from actually construction. Everything was focused or was moving toward, like the slider was moving toward like a more like representational and basically this idea of control, right? Making everything perfect, and how Mario Carpo expressed it, like more allographic type of building, right? Basically making a recipe that someone has to make on site. The problem, I think, is that we can no longer keep making that given these tools that we have right now. Because first, we have like a lot of challenges as humanity. In 30 years, we will be like 11 billion people on Earth. We don't have enough concrete to keep building the same way we're building right now. We have seen presentations, for example, from like remarkable projects like Mark Goulthorpe's Carbon House, where actually he tackles these issues that we don't have enough material or even people to actually build all the housing that we need to build for the next 30 years. So how can we basically integrate again and make new processes where we can use machines, tools, and basically not miss again the opportunity of be part of this revolution. Basically, if we keep like just trusting that someone is going to build for us, we're going to be out of the equation, as we have been like losing participation in that equation of like designing and making our cities. So I think this is an opportunity of saying, okay, what do we do? Why do we need to control everything? Because we know that on site, for example, this is not going to happen. And I agree with Pradeep, what he's saying, that he doesn't believe that this is an implementation that we can do right now. But probably we have to do it. I mean, what I see here at MIT with interesting groups like the robot locomotion group, they are trying to enable this idea of intelligent manipulation, that you can have like this sort of like partners that can collaborate with you, because we will need like help to let's say address the challenges that we have in the future. So I think it's a fertile field of exploration for sure. This idea of going towards like more integration, not only with machines, but with other disciplines, in order to change the way that we build, and not keep like separating us from actually what happens in the end as a built object.
Maybe you want to go? No.
No, Sina, go ahead if you wanna. I want to address the previous question and connect it to this
so
question.
maybe connect.
Yes.
Yeah, maybe connect it to this question and this idea of fail. I would like to tell a short story. So, like 1 year ago, we were invited to this panel discussion by Alfred Yacobi, who was the former dean of the Sao Institute of Architecture. I think he also invited Neil and also me to teach there. And when I was sort of explaining the way we sort of run our studio, he had a very remarkable comment. He said, "It seems that you are sort of doing a car crash test in your studio. So sort of making a sort of experimental setup, and then boom, a crash happened, and then see what's happening." So I think, and then I said, yes. I think what is important is to be able to sort of systematically fail in our explorations. And I think in many of the examples that we see today, it's about this learning from failure, and then whether this learning is sort of implicit learning based on common sense, or whether this learning is through some sort of algorithm. I think it's about sort of learning from this feedback and sort of as I said, systematically fail in this experimental process to be able to come up with a solution which may not fail.
So I want to talk about your previous question about why the research, can the research address the real problem? And I want to mention that, I feel that there is a bigger problem in the structure of research in education. And it's about not continuing the same research. And it happens in a lot of, university, mainly in US, because you are following the funding and the funding is moving and you cannot concentrate in when any research. Comparing this with the other field of engineering, they just address one question for the whole period of 30 years. One faculty is just working on one problem and just constantly, working on that. I feel like, if you want to just focus for 2 years, you're just scratching the surface, you're moving to another topic. So it's more about how you can restructure the research in a way that you can have this moment of, try and error and, getting to the point that you can take it outside. And so I feel like this is a bigger problem that needs to be addressed. And I wrote it in my Arcadia statement that it should be addressed through us as an educator that has a research component in our job description, that we have to redefine the research in architecture in a way that having this moment of taking care of real problems and not pushing to change the topic of your research constantly to be, I don't know, get the funding, getting other things that is moving along. So that's my main challenge. And I would say that, yes, if you spend enough time on a research, you can get, a really, for example, one institution in one of the biggest contractor in India approached us that they wanted to 3D print a bathroom in million location. And that was perfect job for the robotic, I think, 3D printing. I thought that, okay, it's a replication, it gets, and it's one-story building. It has all the components of this one. But how I could do it when I have, other duties that I have to just, doing that. So it become a little challenging of, addressing real problem in a longer, period in the institution, at least in US.
Yep. May I add something? Because at the same time that we really need to attack real problems is related with the economy, because we cannot think about economy as the monetary, as exchange of, money. Because if we really want to 3D print bathrooms, whatever, or houses, then we need to think in social economy at the same time. And then we have environmental economy. So many of the research of the research are mainly based on questions that are invented by the academia by himself, but it's not related with the context, with the global context. As Diego was saying, probably in the near future, we will not have enough materials. But more than that, maybe in the near future, we will not have another planet, because we cannot keep using, or we cannot be consuming around 2 planets. And that's a problem of architecture, and that's a problem of economy, and that's a problem of research also. And that's a problem also because we are not thinking maybe in attacking the real questions that our society needs. So in a way, somehow, if we don't connect again with our environment, with the social environment, with the planetary environment, if we don't design for the planet, then we'll be designing for ourselves, and then there will be no, let's say, economy by nothing. So if we move forward in order to how to decrease or how to reduce the amount of material and energy in order to maximize performance, in order to maximize structural performance or spatial performance, how we can do much more with less, I think that if we only think about that, then we have a full range of research to do oriented to designing for ecosystem or planetary ecosystems. I don't think that we need to continue, let's say, isolate the research practice, but also the, let's say, the planetary design. So yeah, so the idea of economy, I think that is much more related with the economy of the planet rather by the economy of entrepreneurship or the economy of selling something, to the market.
One problem with that, yes, I agree with Tomas, is that how can you basically bridge that gap between actually what you do in research and the actual applications? If, I mean, I talk about this with people from other fields like mechanical engineering and other fields here at MIT, and they tell me this: why do you keep doing all of these complicated shapes that the only thing that, and they're very honest, make you look irrelevant to the fields that actually you need to penetrate? And that happens a lot in terms of that. I do that myself. I've been doing it, like always exploring like complex shapes and talking about these issues, because of course for us it's important to design and to be like original in terms of shape and procedures and so on. But I think an important question: how do we use the tools that we know how to use and that we can help us think outside the box, as I was writing on the chat, to actually penetrate those fields that are super hard to penetrate with relevant questions, more than just solutions. Another way to break the inertia that we have been involved for many years. So I think that's probably one way to I don't know, to do it, to address these issues.
Totally agree. Do we need to reinvent tools every time that we have a new project? Like every time
probably
that
not.
Yeah, I agree with you.
I think that it's our fault. And again, I go back again to this issue of that every technological change, like breakthrough in architecture.
Everyone have to invent, because it is not shareable. The one who invented, let's say, a specific extruder don't share that. The one who invented a specific machine that do a specific task, he is not willing to share it, because it's all about business. So it's a big point to discuss. I don't have an answer actually.
Yeah, but I think that's an important thing about, do we invent the wheel every time? I think that the important thing here is not about which tool you use, like if it's Grasshopper or Revit, because we are, again, making the same discussion about that. It's about how, for example, you teach students how to think in a better way through these tools, not just to be a better cat monkeys. Sorry for like, I always hated that term, but basically it's what happening again. Like we moved from people drafting, right? They were like paper or like representation monkeys during like the early 19th century. And then we moved to cat monkeys, and now we have bean monkeys or code monkeys. But how do we actually teach them to think in a better way? So it doesn't matter which tool you use or develop. Basically, you can penetrate other fields with relevant questions, and that will lead to relevant solutions, I think.
That is a good point. Yeah, I think we have a future topic in our agenda about ethics. Professor Neil can reflect on this.
Could I ask a question, if possible? I was wondering when I was watching the presentation. I think this is mostly for Diego, but it should be for everyone. I'm always thinking about how you can actually use them in these tools and processes in practice. And by practice, I mean in construction. And we talked about failure, and failure is extremely important when you want to learn and find stepping stones, but is absolutely a big no in construction, because people actually get hurt from failure. So what I'm wondering, these processes and technologies, like how do you see them being applied in construction? Like even physically, is it? I've seen some solutions being machinery transferred in platforms, for example. So they are on site but kind of off site. Other solutions, mostly schematically, they're on site and moving around. Like the practicalities of actually applying these ideas in construction, how do you see them coming about? Maybe it's even like an intuition, it doesn't have to be.
We see that. I mean, I see that like here also at MIT, but not in architecture or design related fields, that the technological solutions are here. We see all the time these mesmerizing videos about like Amazon warehouses, or in China, you know, like controlled by robots, coordinated and so on, or drones like assembling and stuff like that. It's just, again, I'm a little bit like, I'm going to insist on this. when we use that type of technology, I think we're misusing it and missing the point because of probably the way we are, I don't know, tackling problems. In the term that we always focus, or mostly, in the aesthetics, for example, and doing this, you know, fascinating shapes. And again, are topics that Carpo talk about it, and many other people talked about it in the past, like probably 20 years ago, 10 years ago, we're again in the same discussion. It's like, how can we penetrate again and talk with other disciplines that they also see a value in what we do as architects or designers. For example, design right now is super trendy in education. Like every engineer wants to penetrate design fields in order to learn how to think in a more creative way, because they see a value in that. And also we are interested also in what they have in terms of tools and math and machine learning and robotics and so on and so forth. But I think we still have a challenge to reach like a middle point, or maybe like a more some sort of like better collaboration in order to start pushing towards the implementation of these things that I think they will be absolutely necessary in the future for construction, for design, so we don't miss the opportunity again. So yeah, I think that
exactly,
that's
and I think following to what Diego is referring to sort of meet in the middle point when it comes to this cross-disciplinary work. One of the reflections, for instance, what we got from the Audi project, where we were inviting like the manager of innovation section of Audi, who was mentioning that actually we are hiring some architects because they know how to deal with the design in a creative way, recent graduate obviously, and they're able to also collaborate. So I think we are sort of changing the practice in a way, but we need to become a bit more self-aware about these capacities that we are sort of creating through this cross-disciplinary work.
Can I chip in something? There's a lot of things come up today. There was discussion as soon as Diego mentioned Alberti, my ears got pricked up, and I don't want to go to Alberti. I think there was some misunderstandings of Alberti. I don't think he's quite the way he's being presented today. I think, anyway, never mind. There are also very interesting questions about failure and errors, which I thought was a great discussion. I was just going to say that I think back propagation, which is essential to AI, you learn through errors, and that's exactly what Jeffrey Hinton says our own brain does. You know, I think that it's absolutely essential to fail and to learn from errors. But I want to pick up on one thing. First of all, I want to thank everybody for the presentation, really interesting presentations today. And everyone keeps thanking us, Digital Futures, but actually we should be thanking you for the contributions you made, because I think it wouldn't have happened without this kind of incredible generosity of giving your time to this. I also want to just, on the side, thank the committee, because these guys are working for free as well, and it's incredible what's happening. I'm really, really impressed. Well, it was kind of interesting to me today to see actually, we had like the Iranian mafia, we had the Chilean mafia, we had the Indian mafia, which is kind of interesting in some ways. So, because actually, I think behind Digital Futures, we were kind of thinking, well, we want to extend this kind of knowledge right across the world to, I mean, I wouldn't want to say the periphery, but that was the idea. But actually, what I'm beginning to realize is actually the periphery is contributing to the center in some sense. And many of you guys are, I mean, you might be working in the States, but you come from other countries. And it's kind of clear from today that actually the knowledge base is actually from all over, which was fantastic. But I've got a question, which, I mean, I didn't realize, I hadn't had a chance to look at all the videos from Digital Futures. I hadn't realized that there were a couple of 2 or 3 workshops that were based on digital fabrication, which of course was a challenge. Everybody was immediately thinking, oh my God, we can't work in the workshop because whatever, But actually, that's exactly the same kind of thinking that started off in the beginning. We thought, well, oh my God, we can't do this thing. We can only go online. That can't do it. We can't really do things online. And then we realized we could. We realized we could do these things. And actually, Zoom teaching, I think, is better than ordinary teaching personally. And also, you can reach out. You can get this incredible kind of, you can live stream
to thousands and thousands of people. So there are possibilities afforded by the digital, which are really extraordinary. And the question I really want to address to you guys, because I think Veronica made a comment, like I'm looking forward to getting back into the workshop in October and doing these things, is, well, maybe we've been thinking the wrong way about the workshop as well, because I mean, initially we thought, oh, we can't do things physical and so on. But actually, if you think about people like sort of Martin Ford, who were talking about how robots are going to come in because of the virus, you know, you actually, they're going to be more present because they don't suffer from the virus. And, you know, you can, actually, maybe they'll become even more important in this situation. So last week, Sumin was showing us how she managed to use AR to operate, you know, from LA to a project in Estonia and to do that in a kind of a remote way. And it strikes me that actually the possibility of remote fabrication is really something that needs to be pushed a bit further. I mean, I had an operation, I was saying the other day, I had an operation for a hernia. And the surgeon was one end of the room and I was the other, right? And he was doing this completely remotely. And I'm just wondering, you know, whether we really don't need to rethink this and actually see that COVID is an opportunity for fabrication in a kind of remote sense. And I'm just wondering if whether any of you have been pursuing strategies in terms of your teaching whereby you can embrace that and use the robot and think about how it can actually be, we can use COVID to our advantage. Yeah, that's my question.
You're mute, Veronica.
Yes, no. No, I think it's a very interesting reflection, Neil. I want to share something that happened to me this last week, 2 days ago, with my students. My students of a studio of 3D clay 3D printing. We are not able to go back to the university, but at the lab there can be 1 or 2 people maximum. So my TA was there. Manipulating the printer with her laptop, pointing the printer all the time, while we were all connected by Zoom, doing the scripts. And but the students were all the time having the camera showing the printing process, so they could have in a real time to see all the problems, all the problems of the mixture of the paste, or the velocity, or whatever happened. And when something interesting was happening, we were saying, okay, what is happening there? So that was super fertile for me, and I think you're right. Robots don't get contaminated, so it's a huge opportunity. And I agree also with the Zoom. Sometimes it can be more effective.
Neil, you know, after having this digital future during the summer, I think it was a moment for me to think about what's going to be the future of education. I thought that the success of that event was fundamental for what's happening, maybe at least in my point of view about the next generation of the studios. I have to teach an advanced studio in architecture. It's about digital fabrication. And in California, we are not allowed to go to any lab. So I haven't been in any lab for 5 months. So, and I started working with other institutions that they have access to the lab, Virginia Tech, Texas A&M, you know, University of Michigan. And we are pairing our studio with them that our student can see the same project happening there. And I think that that's the sharing of the resources. You know, a lot of institutions maybe cannot have robots because of a lot of reasons that, you know, we all know about it. But this opened this type of collaboration that really you can be engaged, not just watching, but working in the context of studio in a collaborative way. So, and I really like this side of, you know, what COVID brought up, that, you know, and I'm starting more collaborative works because there was something, a perception in my mind that somebody that I'm collaborating should be in US. I don't know where it come from. And now I feel that there is no boundary of that. You can work with China, you can work with Russia, you can work with any part of the world if you can, you know, pair up with the research. So yeah.
Okay.
I mean,
We
just to
have
say
some.
I think that's the kind of we're just it's a new world, right? We're discovering all the time new possibilities, and I think that's what we're some of us are thinking about for next summer, maybe for Digital Futures, to try and use that logic whereby you don't necessarily, you can have multiple centers, maybe a network of something whereby there are fabrication centers, but people can enjoy that from elsewhere. This was a comment that Areti made actually in the discussion with Akim Menges, and I think that's a possibility. Yeah.
So yeah, I was thinking that when the Digital Futures happened, it was quite promising. But currently working at the Bartlett, we are still evolving. I feel that we are not yet there that most of the students would be able to enable themselves with the digital education which we have evolved with. But I think we're still understanding between what can be digitalized and what can be actually in physicality, like how we can actually transfer the knowledge of being inside a workshop. The thing is, what most we miss is, or at least I miss since the last 6 months, is understanding the robot space, the space inside a robotic space. How does it move? How does it feel? I think being present inside a three-dimensional space makes more difference as compared to doing everything digitally. One important thing what we have realized is we have just tried to start what can be digitalized, what can be recorded, what can be put on online, and what cannot be done. That's something we're still evolving. Not everything is possible as of now, but at least we are still trying to understand. I think this is the first step in terms of understanding.
Yeah, I was having a question for Diego, maybe regarding this discussion and the revolution of using machines and so on. Your idea of the interactive fabrication system, human gesture and real-time feedback was interesting for me. But I would like to see the future through your eyes. How you imagine the future of what you just started in the age of AI and what we are living in and so on.
I mean, yeah, I mean, it's to be honest, I don't know. I mean, if we go back in time and we see what, for example, Marvin Minsky was predicting that by year 1992 probably or 2000, we will, as humans, we will have been like replaced by robots, right? And design and construction, of course, that didn't happen. And I think one fundamental question about that is why it didn't happen, right? Some people say that it was because of the lack of hardware available at the time, computational power, but I think we're still under the same problems that we need to address. Is that, and I put it on the chat, that, and I agree about like how errors, for example, are like back propagation, and you can basically like learn from errors and become better and optimize and so on. But that error doesn't mean the same for a human that it means for a robot. Let's say if a robot can understand something in the same way as humans. And I think there is a middle ground. I don't think that, for example, Minsky's prediction will ever be fulfilled, that we will not have completely robotic operation or whatever on site, because there are things that, at least not in 40 years. I mean, if you look at what researchers about AI are saying, that we are getting close to probably like a general AI, like GAI, but we are not there yet, because there are a lot of issues that has to do not only with predict something, classify something, optimize something, that has to do with ethics and morals. I don't know if you have seen this documentary on Netflix about killer robots, and actually all the topics that they address in that documentary has to do with that, like autonomous robots. There is this guy, the guy is not a kid anymore, but the guy the first guy who did the jailbreak for the iPhone. He has a company about autonomous cars. And he himself is saying that all of this autonomous cars industry is a scam, because there's no way to have like fully automated robots in the market because of those moral issues. And that is like an emergent and very powerful field now in artificial intelligence. How basically can you decide, for example, if for example, if you're in a car and you're about to hit a person, what does the car do, for example? Do I hit the person to save my life, or do I don't know, jump off the cliff to basically save the person? And those are super difficult things because those are human thoughts, right? And I'm not saying that we are facing the same things, for example, in design and construction, but we might, right? So I think the future, in my opinion, it will be like a mix of things. I would love to see, for example, like people working side to side with a robotic arm on site, right? If I, for example, I'm a worker and I'm performing, for example, like bricklaying, and then a robot can learn from that, and I just leave the robot performing the task, and I can move to another site. I think those type of things combined with this amazing, for example, automation movement that we see, for example, at the Bartlett with the research from Gilles Fredson and others, right? I think it's fantastic. I think because they are pushing also the boundaries to become more efficient and to become like more sustainable, probably. But I don't know, I think we have a long way to go. And I don't know, it's difficult to predict what the future will be like. I have no idea. I imagine, and I would like the future will be like more collaborative, I think. Not fully optimized, but collaborative, to learn also, to have the chance to learn from mistakes and things like that.
Yeah, thank you.
I mean, I think it is already in some ways. I mean, I think that the idea of us versus them kind of thing. I mean, it seems to me that with the discourse is not artificial intelligence so much as extended intelligence or intelligence augmentation, the kind of way which it can become this prosthesis. Although that does have an impact on us, because one person with an AI prosthetic, as it were, could do much more than 20 people before. So things are going to shift in some way. But I just want to take up that question about the dialectic, because there was something that was bugging me about the discussion about Alberti, that I don't know where this idea came from, that somehow Alberti was this kind of intellectual figure who was so remote from the world of fabrication. Maybe it's Mario Carpo, I don't know. But anyway, I think that we have to see.
I think it's Mario Carpo problem, yeah.
Yeah, well,
that's why I have several discussions with him.
I mean, I don't know. I've got problems with Mario Carpo for a lot of reasons. I mean, I don't know how he gets such a prominent platform. But, you know, I think one of the things that we discovered when we were translating Alberti, just to say, I produced with MIT Press the Alberti translation, but it was done it came out in 1988, actually. You think of, that was kind of the end of postmodernism. And one of the issues that we couldn't understand at the time was Alberti's discussion between structure and ornament. Because our idea of ornament was coming out in the 80s was kind of postmodernism. You know, think about all that kind of stuff that was applied to the outside. But then Alberti makes this comment. He makes two comments. One is that the capital is the principal ornament in architecture. We could understand that in the context of postmodernism, right? But then he says, what is a row of columns but a wall with a series of holes cut in it? In other words, he was actually already thinking about structure as ornament and ornament as structure in a very kind of dialectical kind of way. And I think that is true for all sorts of things. I mean, Alberti has got one foot, frankly, in the Gothic tradition, as has Brunelleschi. They came out of that tradition. That's the background from which they were coming. And I think if you want to understand Alberti, you've got to see in the context of someone like Brunelleschi. You know, the discussion about perspective, Brunelleschi invented, Alberti writes about it. But to my mind, if you were to put Alberti today in that situation today, I mean, Brunelleschi for sure will be 3D printing and doing all this kind of stuff, absolutely sure. And I'm sure that Alberti would be obsessed with AI. And the joke I always make is Alberti's name begins in A and ends in I. So in some ways, I think we should get beyond these dichotomies to sort of see things as more kind of in a dialectical fashion. And if you think about Alberti's work, his definition of the architect was all about the moving of weights and the joining of bodies and so on. He actually was thinking about this the whole way. If you look at the illustrations of the first book of a version of De Re Edificatoria to come out with illustrations, they're all about kind of mechanics and how things operate. If you look at Vitruvius also, it's all about mechanics and machines. So I think this idea of this kind of cerebral remote architect, I think that's wrong for Alberti personally anyway, but I'm sure others would disagree with me on that, but yeah.
No, just to be more polemic about this. I think that, yes, history of architecture is built in like philosophy and other fields of knowledge that is building with misunderstanding things, and we misunderstand Alberti, and at the same time all our history is based on Vitruvius' book. We never see it, we just see translation and translation of Vitruvius' book. So, and we have all the history of architecture building based on this book and we never see it. Bernard Cash say this about, so I would like to ask, what should be the history of architecture in terms of yes, authority also, if we never read Alberti, because all our idea of authorship is based on Alberti thing that is separated the intellectual idea from the building site. So, or maybe some misunderstanding of Alberti. But anyway, I think it's a good question to rethink, to desacralize some text that we have in the history of architecture. I think that Mario Carpo is obsessed with Alberti. I don't share Mario Carpo's point of view. He knows that we have several discussions about this. But I mean, anyway, I don't know. It's just a comment just to be more polemic about this.
But maybe I can be even more polemic about that, because I was translating Vitruvius after Alberti, and I did a sample translation. And anyway, I was actually eventually invited to do it. I didn't have time. I'd moved to different things. But one thing I would say, if you focus on Alberti, what is totally disingenuous about Alberti is actually he relies almost 90% on Vitruvius. He doesn't mention that, he doesn't acknowledge that, doesn't put in a footnote kind of thing, but he's kind of so actually it goes back to Vitruvius. The one problem about Vitruvius, I mean, just in terms of translation that I found, was that Alberti's super sophisticated in terms of language. He invented the Italian language, basically, the first person to write in Italian. He didn't invent it, but it was a kitchen language. He turned it into a proper language. But Vitruvius was like your kind of typical jobbing architect, and his way of writing was just, it's kind of very basic. And how do you translate that without, I mean, you can't make it sound too mellifluous when it's such bad Latin. But anyway, but I think that in a way it is, I think we have to sort of break down these distinctions between Vitruvius Alberti, between structural ornament, between the intellectual and the practical thing. I think all of these things are kind of historical misconceptions of things.
Yeah, I agree. Yeah.
So in this context, I'm a fan of Brunelleschi for sure. Okay.
I knew it.
Yeah, like if you look at the architecture and his approach, I think I like the point that maybe he was Enrico Dini of that time.
Question.
Do you still have questions? Okay. Thanks for everyone.
Look, just why I just want to say something, Ahmed. I think that I was kind of listening to my own closing remarks the other day about this thing, and I in a way, we have this platform, and it's what is great is to bring back this team that just thank you so much for contributing to Digital Future. It was amazing. But I think it's it is a collective thing in many ways, and how do we chart the future? How do we find some way of moving forward? And I just think that it's literally the Wild West at the moment. Nothing has been defined, and the space is out there, and we have to kind of in some ways start thinking, because this is a new regime. I really don't think we're going to go back completely to the old one. And all these affordances, these opportunities are opening up, and it'd be great if everyone could contribute in some way towards trying to promote this kind of new platform that in the end, it's always been about bringing ideas for free to everyone around the world. So I'd like you all to kind of to spread the word and things, and to try and make the most of this, because I think this is an important. The way we're thinking about it anyway is to think it in some ways it's a bit like a TED talk, and increasingly we're going to have a thematic discussion. So they're going to be like AI. So some mix between a TED talk, a TED talk and an AD with some thematic discussions. So I would just invite you all to contribute in some ways. I think these discussions are absolutely wonderful, and I think they're incredibly rich, and they need to sort of go on in some way. But it'd be great if you guys could all join in some way to be part of it. It's been a great experience. Anyway, so I want to thank Ahmed today for taking on board this thing. I'm blown away when we can kind of parachute into Egypt and Chile and whatever else. It's amazing. Thank you, Ahmed.
Thanks for the presenters. The most important thing, point of view from my point, to the audience, is to believe that you can change the world to a better place. So please do your best, believe in yourself. On behalf of Digital Futures, we are waiting for your contributions and submissions regarding our next call. The link will be posted on YouTube and on our Discord channel. Our discussion today was amazing, exciting. Personally, I have a lot of questions not answered yet, but let's move forward. I would prefer to extend the session for days, but unfortunately, we run out of time.
I mean, just talking about time, when the robotic fabrication student submissions is still open until how long?
I think today.
Okay, the end of today. Okay.
Today, I mean.
But today vary between where you are.
the latest today possible.
Yeah. Yes. So the discussion is just started. We'll be waiting for you on our Discord channel. Thanks for everyone. Thanks.
Today is already tomorrow in China, right? And also Australia. But then, let me just kind of say something. I think we should. That's also a distinction we should break down. You know, there's a comment that I think that Wolf Pricks once made. The title of a lecture at SciArt, and it was "Tomorrow, today will be yesterday." And you know, we should think about that. And I think therefore, and also
what a happy day.
In the context of Alberti, don't think about him as a historical figure. He was absolutely, completely contemporary, futuristic in his way of thinking. So those who kind of like dismiss him as being part of the past, he's actually, you know, anyway, whatever, lecture over. But,
yeah,
even Peter will agree with you about this.
Yes.
Still translating Verdi, so.
Thanks for everyone.
Thank you.
Thanks everyone.
See you next Saturday.
Thanks, guys.
Yeah.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.